we're going to talk about what are called flowchart paragraph proofs. These do get used. The two-column proof is the most common. And a flowchart proof is more often used in programming and trying to determine a sequence of operations than it is for this, but it does lend itself to it when we have to do certain things in certain order. And a paragraph proof is simply just a paragraph explaining why it is what it is. Now, so the flowchart proof should be read from left to right or from top to bottom. That's mostly what we read things, top to bottom, left to right. Each part of the proof appears in a box, while the justification is written under the box. It's another form, and then the arrow shows the progression of the proof steps. So it puts things in order a little bit more. In a two-column proof, we can write things out of order, but as long as we've got the same, all the pieces there, we can make a conclusion. Now, with the flowchart, we have to make sure that we put it in the proper order, and it's going from step 1 to step 2 to step 3. So, let's take a look at this. We need to interpret what is going on here. We are given that angle 1 and 3 are congruent. We are given that 1 and 2 are supplementary. We are supposed to prove that 2 and 3 are supplementary. Okay? Now, as it starts off here, it says, okay, that's given. Start there. And that means that the measure of angle 3 are the same. You have to remember that measure and congruent shapes are two different things on there. We don't always go through and do that. We usually got an idea, okay, hey, we know these are the same, this is the same, this is how we come up with them. So, they change congruent into the measures being equal. These are supplementary, measures add up to 180 degrees. And the reason that we have to make sure that we go to measures this time is because we're using this idea of supplementary, and supplementary means that the measure of two angles adds up to 180 degrees, not just that the shapes are the same size. So, we know that measure of 1 is equal to measure of angle 3. We substitute in here, and we can say that those two measures equal 180 degrees, and that they are supplementary. That's just how it's done. But can you see the path that it's following? Do you sort of kind of see the progression that it is giving? Now, I realize that you're looking at this and it's like, well, yeah, so what? They mean the same thing. You have to try and put it into your mind what is necessary for solving. What will answer the question? It simply takes time. Now, so I want to go through here and I want to write a flow chart for this one. Okay? Given triangle ABC. Well, what does that look like? Are we going to put that in a box to begin with? Is that how it starts off with? What do we got? We're given a triangle, and we're given what? Prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Now, what they have done here is it kind of thrown things out of whack here for you, because they've got this dotted line up there. It kind of looks like it's there to begin with. The problem is, it's not really there. And how in the world would you ever know that? You wouldn't. given this picture. It's unfortunate that they started off like that, but that's the way it goes. Anyhow, what we've got here is they drew this line. Now, can I always draw a line through anything that I want? If I've got a point, can I just draw a line? Sure, I can draw a line through a point. That's perfectly capable. Can I draw a line through a point with certain conditions? Is that possible? Sure. As long as I go through and state it. So what they ended up doing here is we have, they wrote it out like this. Draw a line parallel to CB through A. Line. No? Parallel. Can I go and use the postulate that says through any one point there is going to be a line parallel to another one? And only one line. Can I use that idea? Okay. Now the reason why I want to use that idea is I need to come up with, because it says the sum of the interior angles. This, if I got interior, do I also have exterior? Does that make sense? Yes, no, maybe so. See, if I don't get any feedback from you guys, if I just see you there with your hands, with your head in your hands, staring at it, and going, what is he talking about? You'll never get it. You won't understand it. And if I see somebody kind of shaking their head, no, they don't get it, well, I can try and reiterate it in a different way, try and get you to understand it in a different form. So now, I've done that much, okay? I'm going to move down to the next part. Well, if I do that, what's going to happen here is actually, I'm going to have to do two things at one time. I'll show you what all that looks like. One, it's going to go this way, and I am going to say that, let's see, angle 1 is congruent to which angle? Which one? If that dotted line is parallel going through CB, angle 1 would be congruent with which angle up there? I hear somebody say 4. I hope they said 4. Congruent with angle 4. Wouldn't that be AIA? Could I go and say that angle 3 is going to be congruent to angle, which one now? I. Okay. And that one is going to be by, again, angle, or alternate interior angles. Now, we've got measures here. So should I go and change the measure or congruence into measures? Is that the next step that we have to do? So this one here says that the measure of angle 1 is going to be equal to the measure of angle 4. This one says that the measure of angle 1 is going to be equal to the measure of angle 4. Why? Definition of congruence. Okay. Now, remember, we want to try and get to this, that we're supposed to prove that these three equal 180 degrees. Now, how this ends up working, and I wrote that wrong over there, didn't I? That was supposed to be 3 and 5. So what I've done, I've drawn a line through it. Do I know what 4 plus 2 plus 5 add up to, by the way? 180 degrees, because they're on one side of a line, right? So if I have all the angles on one side of a line, do they always add up to 180 degrees? No, they have to. They're on one side of a line. So, since I know they add up to 180 degrees, I know a triangle adds up to 180 degrees. I know 1 and 4 are the same, 5 and 3 are the same. I can now go through and say that, let's see, we go down here. Measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equal 180 degrees, correct? This is going to get, I know, this really looks confusing, doesn't it? Why in the world is it doing what it does? There are 3 things that I need to get down to make this statement that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equal 180 degrees. I needed this piece of information, correct? That 3 was 5. I need this piece of information, that 4 is 1. I need this piece of information, that they are going and adding up, okay? So, this was just simply by substitution. And this is definition of straight angles. Now, do you understand and kind of see why the other proof is a lot easier? All we are is making the statements and putting it together at the end because I have this, 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 and this. I've got everything there. This is a lot more complicated because you have to make sure that you get things in proper order. So, now a paragraph proof is probably the easiest one out of the bunch. There is no form. We just need to make sure that we write everything in a paragraph, almost like we would say it. Okay? It says in a paragraph proof, every step of the proof must be explained by a sentence in the paragraph. Each sentence contains a statement and a justification. So, if I take a look at this, what I've got here is pretty much my paragraph proof. Okay? We're told that 1 and 2 are complementary. Prove that 3 and 4 are complementary. So, it says 1 and 2 are complementary, so I know that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees by, definition of complementary angles. We know that angle 1 is congruent to angle 4, and that angle 2 is congruent to 3 by the vertical angle theorem. So, again, this is very similar to going and doing the 2-column proof. You don't have to worry about putting things in a specific order. You just need to be able to make the statements so that they're all there so that you can tie it up at the end. So, we know that measure of angle 1 is equal to measure of 4, measure of angle 2 is equal to measure of angle 3 by substitution. 4 plus 3 equal 90, therefore 3 and 4 are complementary. But again, you have to know what the rules are. Those definitions, the theorems, and the postulates. You have to know what that is and be able to go and follow through with what it is. So, if I want to write a parallel or a paragraph proof here, I want to prove that angle 2 is congruent to angle 3. So, If I want to prove that angle 2 and angle 3, it says if two lines are cut by a transversal, then alternate interior angles are congruent. Okay? So I can't use alternate interior angles. That's what I want to get to. So, could I start it off something like this? Given that, let's see, line P and Q are parallel. Okay. What could I say next? What would be good to say? I've only got really three things there. I got 1, 2, and 3. I got to say that 2 and 3 are the same. What might be something that I could say based upon what I see? Could I say 1 and 2 are congruent? And that would be because of what? Vertical angle. So, I mean, state what's there. I see that 1 and 2 are there. Okay, so we know that angle 1 is going to be congruent to angle 2 by vertical angle theorem. Okay? Is there anything else that I could say? 1 and 3. Okay, so what allows me to say, and I could say, and angle 1 is congruent to angle 3 by what? There we go. We're in the same spot, so corresponding angles. By corresponding angles. So, can I go and say that something is equal to something else now, or congruent to something else? What's the one that I can use? Transitivity. So, I could say, period, by transitivity, angle 1 or angle 2 is congruent to angle 3. Because 1 is congruent to 2, 3 is congruent to 1, therefore 3 has to be congruent to 2. Did I explain it? Did I go through and state it? Do I have enough justification? Does it have to be perfect? It does not. It should be logical, it should follow a pattern, that if you look at it, it makes sense to you. So, what I want you to do is I'm going to give you a few minutes here, and I want you to go through and write out a 2-column proof based on the information that you see there. Translate this into a 2-column proof. All right. So, how this should look translated over. Now, yours might be a little bit different. That's fine. But we would say that angle 1, angle 2, complementary, angle 1, congruent, angle 3. This was all given to us. Okay? So then we've got the measure of angle 1 plus the measure of angle 2 is equal to 90. Okay? Definition of complementary angles. Measure of angle 1 is equal to the measure of angle 3. Definition of congruent angles. Okay? So, what's the next statement that they got here? Measure of angle 3 plus the measure of angle 2 is equal to 90 degrees. Here they did substitution. Angle 3, angle 2 are complementary. Definition of complementary angles. There you go. The two-column proof is a lot shorter, doesn't it? Looks a lot more compact and a lot neater. It's the difference really between having the stuff all together and saying, hey, I've got all the stuff to make this, and versus the steps and the recipes, how to do the steps. So, I'm going to give you another 5 minutes here, and I want you to try and put together a flowchart proof based upon what you see. All right, see, come up with here. Now it says, given A and B are intersecting lines. So we've got box, A, B, intersect. And of course that is, okay. It says 1 and 3 are congruent. So what should where should I go now? 1 and 2, okay? So I'm going to say that the measure of angle 1 plus the measure of angle 2 equals something, right? Won't that be 180 degrees? Okay. And that would end up being definition of supplementary angles, right? Could I also then go through and say that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees? Okay, that would make sense to do, wouldn't it? And again, that is also a definition of supplementary angles. Could I then say that, let's see, okay, I've done that, I've got that 2 in there. I got to get that 1 and 3 are congruent, correct? So, from what I've got up here, can I go and state that the measure of angle 1 is equal to the measure of angle 3? Okay, why should I be able to say that? Not necessarily, because I don't know that measure 1 is equal to measure 2, and that it goes on with that. Could it be a substitution? Yeah, because I mean, I've got angle 2 in both one. One says 1, one says 3, so we got to have a substitution in there that allows for that. So if they're that substitution, then I can say that angle 1 is congruent to angle 3. Definition of congruence. Now, again, this is going to be a little bit more on the specific side, but I'm not concerned so much about making sure that you get the statements in exactly the same order. There's going to be a little variation from what you see. I just want you to be able to take a look at this, identify what things should be identified as being equal or congruent, or what you can put together, and make sure that you have the correct rationale behind it. So, let's see. I'm going to give you 3 minutes, and I want you to go through and do this. So I got to get a two-column proof from this. Now, the nice thing is, because these are all in sentences, we can pretty much pull out the information we need from what we've got. So it says 1 and 4 are complementary. That was a given. So we have angle 1, angle 4, complementary, and that would be given. So measure of angle 1 plus the measure of angle 4 is equal to 90 degrees. Why do we know that? Because the definition of complementary angles. Now, it says angle 1 is congruent to 3, angle 2 is congruent to angle 4. Right? Angle 1 congruent to angle 3, angle 2 congruent to angle 4. Why? Vertical angles theorem. Now it says therefore. Now one of the little things that you can kind of catch up with here is this therefore. That means that we're concluding something. Based on information that we have, we can go to this now. That's what the therefore means in here, so it means we're getting close to the end. So, we've got measure, whoops, that's the wrong one. Measure of angle 1 is equal to the measure of angle 3. Measure of angle 2 is equal to the measure of angle 4 by what? Definition of congruent angles, it says. And we get measure of angle 2 plus the measure of angle 3 is equal to 90 degrees. We got a substitution. Therefore, it says angle 2, angle 3 are complementary. Why? Definition of complementary angles. It's just learning how to read and pull the information out. Realize it's not one of those fun things, but it's pretty much this idea of step by step. Given this, you have to do that. You have to understand that it's something that you need. So, you can stop it right there, and you've got a little time to get started on your assignment.